Hello students! Today our goal is to add and subtract rational expressions. Remember, when I say rational expression, I just mean a ratio of polynomials. When you hear that word ratio, you probably should think that we're going to be working with some fractions today. We've all added and subtracted fractions before, specifically with just plain old numbers. So I want you to go back to your beginning days with fractions and try number 1 on your own. Okay, this means pause the video, complete the work, and then turn it back on when you're ready to check the answer. So don't cheat and look ahead, and good luck. Okay, I hope that wasn't too tricky for you. Check your work with mine. Let's talk about this really quickly. So the very first thing you need to do when you are adding or subtracting fractions is always find a common denominator. So for example, in this problem, the only thing 6 and 10, or the smallest thing 6 and 10 have in common, is 60. So you have to multiply 1/6 by 10 and 1/10 by 6, which brings me to this step here. Once you have a common denominator, then you can go ahead and add the numerators. Add across the top, okay, since they're both over 60. And finally, when you're done with that, you can simplify. So you should be looking for a common factor that you can cancel out from the top and the bottom. And you should have gotten that the final answer is 4/15. So why in the world am I talking about adding fractions when we're in Algebra 2? That's because we want to use these exact same principles to add or subtract rational expressions. So the very first thing you should do when you look at a rational expression is ask yourself, what's the common denominator? Or is there a common denominator? So if I'm looking at number 2, 5x and 5x are exactly the same. So luckily in this problem, step 1's already done for us. So now we can go to step 2 and add the numerators, which is 3 plus 7 gives us 10, over our common denominator. And lastly, we can simplify. So keep in mind we're looking for common factors we can cancel out. So we know 10 factors out into 2 and 5. 5x is 5 and x. Okay, why am I writing this out? Just because sometimes we'll want to cancel things when we can't, but since 10 is 2 times 5 and 5x is multiplication, you can go ahead and cancel a factor of 5. So all that's left is 2 over x. Okay, keep in mind they have to be multiplied for those factors to cancel at least. Number 3. So we have 4 over 5x minus 2 minus 10 over 5x minus 2. So right as I'm reading the problem, I notice that both denominators are 5x minus 2. So yay, I get to skip the first step again, and all I need to do is subtract, in this case, the numerators. Now the question is, how do I subtract 4 minus 10x? And again, I write that over my same common denominator. And the answer is, since they're not like terms, you can just leave it like this. Okay, but you need to ask yourself, is there anything I can simplify? Remember in this problem up here, I said you had to have multiplication to cancel factors. Same thing applies here. Okay, so the only things we could cancel are factors that are multiplied. I can't just go ahead and cancel both of these x's because I see them there. Okay, the reason you can't do that is because they're separated by subtraction signs here. So what you could do is you could try factoring out a GCF in the numerator and the denominator. So the numerator, they both have a 2 in common. So you have 2 minus 5x left over. In the denominator, you have 5x minus 2 left over. Now you may be thinking to yourself, these look pretty similar, except one has a negative 5x, one has a positive 5x. So what could we do to make these exactly the same? Okay, if I want to make the numerator look like the denominator, instead of factoring out a 2, I'm going to have to factor out a negative 2. Okay, and then what's going to be left over is negative 2 plus 5x. Okay, if you distribute that out, you'll get a positive 4 and a negative 10x. Now I know that still doesn't look identical to the denominator, but we can always switch around the order because addition is commutative. So I can rewrite this as negative 2 times 5x minus 2 over 5x minus 2. And, oops, didn't need those parentheses there. 5x minus 2. And now these look exactly the same. So notice these are being multiplied, which means I can cancel factors now. If these are identical, we can get rid of them, and our final answer is negative 2. Key in this problem is that you can only cancel factors that are being multiplied. Otherwise, they wouldn't be factors. They would be things you're adding to them. Number 4. Number 4 looks like a real doozy, and the reason we practiced factoring before is so we could make these problems a little bit simpler when we have some ugly polynomials here. So what I want everyone to do before we complete this problem is on your own, factor these polynomials. Think about the different tricks we used, and I will come back with the answer. So pause the video. Okay, just having factored the denominators, I can rewrite the first one as x plus 3x minus 3, second one is x plus 3x plus 5. If you still don't feel comfortable factoring, it's going to be used forever and ever, so please go and get help. Now, going back to our ultimate goal of subtracting these two rational expressions. Remember, the first thing you always want to do, and we haven't done this since the first problem, is find a common denominator. So our first denominator is x plus 3x minus 3. Our second one is x plus 3x plus 5. So remember, you're looking for common factors. Okay, when I was looking above here, 10 and 6 gave us a denominator of 60. You're looking for what can I multiply x plus 3x minus 3 by to include all the factors in x plus 3x plus 5. And notice this one already has an x plus 3, so we're good there, but it's missing an x plus 5. So this first fraction I'll have to multiply by x plus 5. And if you do it to the denominator, you better also remember to do it to the numerator. Okay, you're going to do the same thing with the second fraction. Now I have an x plus 3 in both of them. I have an x plus 5 in the first one and the second one also. But what this fraction is missing is this x minus 3. So I'm going to go ahead and multiply the denominator and the numerator by x minus 3. This looks pretty ugly, but now we can write it as one big fraction under one big common denominator. Okay, so each of them has an x plus 5, an x plus 3, and an x minus 3 now. Okay, and before we can do anything else, we need to simplify up the numerators of each fraction, and then eventually we're going to be subtracting them. Okay, so if you're going to multiply x plus 5 by 2x plus 1, you're going to have to FOIL, and then you'll have to multiply 6 times x minus 3. So I want you to clean those up, just multiply them out, and I'll come back with the full simplified numerator. Okay, all I've done is multiply out the first fraction that gave me this, the second one distributed to get 6x minus 18. Okay, keep in mind that we're subtracting the two fractions, and when you're subtracting polynomials, please keep the second one in parentheses because we all know we need to distribute this negative sign. So all of that factoring, all of that multiplying polynomials, and all of that adding and subtracting polynomials is going to stay with us forever and ever. Once again, please get help if you do not remember any of these topics. Okay, so now we can clean up the numerator by subtracting 6x minus 18, which is really like adding negative 6 and adding 18. Okay, so our x's we can combine. We only have 1x squared. So we have 11x minus 6x, which will give us positive 5x. And we have 5 and 18, which will give us positive 23 over our common denominator. X plus 5, nothing's changed here yet, and nothing's changed here. So the last thing we need to do is see, can we simplify this? And remember, you can only cancel factors if they're being multiplied. So the denominator is good to go, everything's being multiplied, but we need to see what this polynomial would look like as written as factors. In other words, we are going to see if we can factor this polynomial. Every time I factor, I'm going to go through that factoring flowchart and say, first of all, can I pull a GCF? No, I cannot in this case. Next is a special case. No, it's not. Then I'll either use AC or guess and check. Now, I'm looking for numbers that multiply to 2 times 23 and add times 5. And this particular problem is actually not factorable. So I actually don't even need this equal sign because I can't factor it, which means there are no factors I can cancel, and this would be my final answer. Okay, but to add on to our steps here, in order to simplify if it's a rational expression, you're going to have to make sure it's in factored form, okay, before you can cancel. There's one more problem on the back. It's a doozy. What I want you to do is try it on your own. And I've said this before, but the most important thing you could do is to take the problem in chunks. So if I covered this up for a second, this looks like a problem we did above. Okay? Just keep in mind you want to go through the whole process and see if you can simplify as much as possible at the end. Once you're done with that part of the problem, then you can go ahead and subtract this whole fraction using the same process we did before. So please try that on your own. You're going to test yourself and see, did I get what I needed to get out of this video? And come to class with all those questions you had written down right on your notes. Good luck, have a good night, and see you tomorrow.